Space is incredibly massive. There are around 100 billion stars in the Milky Way galaxy alone, and there are many, many more galaxies with even greater amounts of stars. Putting the whole universe into scale is, well, not quite possible. So, instead, we will focus on putting our celestial neighborhood to scale. So, our first stop is the Sun, also referred to as Sol. Our Sun is a yellow dwarf star with a radius of 695,697 kilometers. It has an average temperature of 5,778 Kelvin and is the center point of our solar system. Here's the first planet in our solar system. This is Mercury, positioned 0.39 astronomical units from the Sun, with a mass 5% that of Earth's. It has a radius of 2,440 kilometers and an average surface temperature of 100 Celsius. This here is Venus, the second planet in our solar system. It is 0.723 astronomical units from the Sun, has a mass that's 81% that of Earth's, a radius of 6,052 kilometers, and an average temperature of 463.46 Celsius. Now, here's a more familiar planet. This is Earth, third planet in our solar system. Positioned 1 astronomical unit from the Sun, it has a radius of 6,371 kilometers and an average temperature of 9.3 Celsius. Earth is also the closest planet to the Sun that has a moon. Here is the famous red planet. Positioned 1.52 astronomical units from the Sun, Mars has a mass of 10.7% that of Earth's, an average surface temperature of negative 46.46 Celsius, and a radius of 3,390 kilometers. Mars also has 2 moons, Phobos and Deimos. This is Jupiter, the 5th planet from the Sun and by far the largest. Positioned 5.2 astronomical units from the Sun, with an average temperature of negative 110.47 Celsius. It has a radius of 69,911 kilometers and a mass that is 317.8 times the Earth's mass. To date, Jupiter has 95 known moons. This is the ringed planet Saturn. Saturn is the 6th planet from the Sun, positioned 9.54 astronomical units from the Sun, has an average temperature of minus 140.87 Celsius, a radius of 60,268 kilometers, and a mass that's 95 times that of Earth. Saturn beats Jupiter in terms of known moons, coming in with 146 moons. The 7th planet from the Sun is Uranus. Positioned 19.19 astronomical units from the Sun, it has an average temperature of negative 197.21 Celsius, a radius of 25,559 kilometers, and a mass that is 14.5 times that of Earth's. Uranus ranks 3rd place in the amount of moons it has, that being 28 different moons. And finally, we reach the 8th and final planet, Neptune. Positions 30.07 astronomical units from the Sun, it has a radius of 24,622 kilometers, an average temperature of negative 201.5 Celsius, and a mass that is 17 times that of Earth. Neptune also has 16 different moons. Alright, this is cool and all, but how does it help us put the solar system into scale? Well, my friend, it really doesn't. However, I do have a way to represent the scale of the solar system. Minecraft, an indie block game developed by Notch in 2011. Everyone has at least heard of this game, and I'm sure if you've ever played it, you're quite familiar with the scale of the game. It's massive. With a world border placed over 30 million blocks from spawn, it gives us the perfect tool to represent scale. So, let's get started. The first problem we run into is Minecraft is very blocky. Representing the solar system will be difficult if we don't establish a few things first. Radius is defined as the distance from the center of a circle to its circumference. In Minecraft, we will represent this as the amount of blocks from a center block. For example, this black concrete block is very center. A radius of 1 would be defined as 1 block from the center, like this. 2 would be 2 blocks, 3 would be 3, 4 would be 4, and so on. An example of a more three-dimensional object would be this. This sphere has a radius of 3 blocks. As you can see, we look at the center block, count 3 outwards, and we reach the outside. Now, let's get to scaling the solar system. First thing we need to cover is getting a unit of measurement. Because Minecraft doesn't allow for placing anything less than a block unless we add the chisels and bit mod, so we will say this is Mercury. As you may note, it has a radius of 1 block. We can count 1 block from the center and reach the outside. This is perfect! It gives us a measurement unit we can work with. 1 block equals the radius of Mercury, which is 2,440 kilometers as I mentioned earlier. How much is 2,440 kilometers? Well, to put that to scale, it would be the distance from Seattle to the bottom right corner of Kansas. With all that instated, let's get to the math. First, we will figure out the radius of every planet in terms of the measurement system I defined. So, let's take Mercury's radius. Mercury has a radius of 2,440 kilometers. Purely to make things more convenient, we will label this as 1 Mercurian unit, or 1 MU for short. As I defined earlier, Mercury's radius is equal to 1 block. So with that said, let's take the radius of the Sun. 695,698 kilometers. If we divide this by our Mercurian unit, we get 285 blocks for the Sun's radius. You may wonder, what's the squiggly equal sign for? This represents rounding. Minecraft blocks are represented in full numbers, and if I don't round, I would get a number like this, which cannot be represented in blocks. So, after all that, we figure out the Sun would have a radius of 285 blocks. Now, for the first planet in our solar system, Mercury. Well, we know Mercury's radius is 1 MU, which is equal to 1 block. After a bunch of algebraic rearranging, we can get Mercury's radius equals exactly 1 block. Now, let's take Venus's radius of 6,052 kilometers, divide it by 1 MU, and we get around 2 blocks. Now we take Earth's radius of 6,378 kilometers, divide it by 1 MU, and get around 3 blocks. We can repeat this process and find that Mars has a radius of 1 block, Jupiter has a radius of 29 blocks, Saturn has a radius of 25 blocks, Uranus has a radius of 10 blocks, and Neptune also has a radius of 10 blocks. Now that we got the radius of every planet, we can focus on their distance from the Sun. A helpful unit for us to know is called an astronomical unit. This is the distance from the Earth to the Sun, and it is equal to 149 million kilometers. We will shorten the astronomical unit to AU. Now, let's figure out how far the first planet in our solar system is from the Sun. Mercury. To find this, we will take Mercury's semi-major axis. You may wonder, what is the semi-major axis? Well, the semi-major axis is the average between an orbit's perigee and apogee. We will shorten the semi-major axis to SMA. Now, what does perigee and apogee mean? Let's take an elliptical orbit model. The apogee is the point at which the orbit is furthest from the Sun. The perigee is the opposite. It's where the orbit is the closest. With that said, let's take Mercury's perigee and apogee. Mercury has a perigee of 0.307 astronomical units and an apogee of 0.466 astronomical units. Recall the formula I introduced defines our semi-major axis. When we plug in the terms, we find Mercury has a semi-major axis of 0.3865 astronomical units. Now, let's take this value and convert it to blocks. First, we multiply this value by 1 AU and get 57,820,400 kilometers. Take this value, divide it by our already defined Mercurian unit from earlier, which tells us Mercury will be placed around 23,000 blocks away. Now we are getting somewhere. Now onto Venus. Venus has a semi-major axis of 0.723 astronomical units. Multiply the values, and that tells us Venus has a semi-major axis of 108,160,000 blocks. Divide by our Mercurian unit, and find Venus is 44,000 blocks away. Doing all this work is getting pretty annoying, so let's create our own function of distance that converts any value from astronomical units to blocks. A formula for this would look like this, where value d represents the distance in astronomical units. So for Earth, let's plug in Earth's distance of 1 astronomical unit into the formula, and we find that Earth is 61,000 blocks away. Now let's take the formula again and plug in Mars' semi-major axis, and we find that Mars is 93,000 blocks away. Now let's take Jupiter's distance. We see it's 318,000 blocks away. Repeat for Saturn, get a distance of 582,000 blocks. Do the same for Uranus, get a distance of 1,175,000 blocks. And finally Neptune, where we get a distance of 1,843,000 blocks. Alright, with all that said, let's get to demonstrating the scale. Up first at 0, 0, we have the Sun. As you can tell, it is absolutely massive, with a radius of 285 blocks. Second on the list is Mercury. Positioned 23,696 blocks away from the Sun, it comes in with a radius of 1 block. Third, we have Venus, which is even further, at 44,328 blocks, and it comes in with a radius of 2 blocks. Fourth, we have Earth, coming in at 61,311 blocks, it has a radius of 3 blocks. Fifth place, we have Mars, coming in at 93,439 blocks away, with a radius of 1 block. Sixth, we have Jupiter, coming in at 318,820 blocks away, with a radius of 29 blocks. Seventh, we have Saturn, 582,459 blocks away, with a radius of 25 blocks. Uranus, at 1,175,954 blocks away, with a radius of 10 blocks. And then Neptune, which is 1,843,028 blocks away, and it also has a radius of 10 blocks. And, with all that said, I hope that anyone watching this video, that this helped you at least understand the sheer scale of our solar system a little better. So, thank you for your time, and goodbye.